Exponents, part 2. Here we go. So we're going to pick up where we left off yesterday. And we talked about what we just called rule number 1. First rule, which is x to the n, it's an m, times x to the m equals x to the n plus m. And we said that x could be anything, n could be anything, m could be anything. So as an example of that, we might do something like -3 to the 5th times -3 to the 12th. And we talked about if x is a negative number, we have to put it in parentheses to show that the negative goes with the number. We talked about that yesterday. So in this case, my answer also, I have to keep that -3 in parentheses, and then I just add up 5 and 12 to get 17. There's one step with this that we didn't talk about yesterday, and it was on your homework. I don't know if you noticed this. So when I have a negative number raised to a power, and by that I mean a negative number inside parentheses, I can actually simplify it. So if I have -x raised to any even power, any even number, that's actually the same thing as x raised to that same number. So -x to the 8th power is the same thing as x to the 8th power. -7 to the 12th power is the same thing as 7 to the 12th power. So I can actually get rid of negatives, and we love getting rid of negatives. Negatives get so annoying. But this lets us get rid of them. Now I have no negative in my answer. Right? I have a negative number in parentheses raised to an even power. I simply rewrite it as that same number without the negative raised to the same power. So I have the same base, same power. So let's do an example. If I had -5 to the 10th power, what does that equal? That's the same thing as just 5 to the 10th power. Right? Why is this? Well, the reason is that when I multiply negative numbers, if I have a negative, let's just say -1, times another negative, that makes a positive. Negative times a negative is a positive. So what if I have like a negative times a negative times a negative times another negative? Well, watch what happens. I start with a negative. Now I have a negative times a negative. That makes a positive. Right? Now I have a positive times a negative. That makes, now I have a negative again. And then I have a negative times a negative. In the end, I end up with a positive. So each time I multiply, I switch my sign back and forth. Negative times a negative is a positive. A positive times a negative is a negative. A negative times a negative is a positive. So if I'm multiplying a negative number an even number of times, those negatives all cancel out. Right? Watch what happens. Let's say I had this example, -3 to the 6th power. That's the same thing. Remember, with our definition, we can always write it out. -3 times -3 times -3 times 3, 1, 2, 3, 4, 5. Oh, I'm running out of space. Let's make these ones a little smaller. 1, 2, 3, 4, 5, 6, negative 3. So all multiplied together. So what do these two become? Two negatives makes a, just talk about the sign. Negative times a negative makes a positive. What do these two become? A negative times a negative makes a positive, and a negative times a negative makes a positive. So do you see, when I have an even number, each pair of them multiplies together to make a positive. Questions on that? So what about when I have an odd power? So if I have an odd power, I can simply get rid of the parentheses. If I have negative x to an odd number, that's going to be negative x to that same number. In other words, if I had negative x to the fifth, that's the same thing as negative x to the fifth. So now, I'm eliminating the parentheses, but I still keep my negative sign. So when I have an even power, I get rid of the negative. When I have an odd power, I have to keep the negative. So what would this be? Negative x to the 7th power is the same thing as negative x to the 7th power. What about this? Negative 3 to the 5th power. What would that be? Yeah, just with no parentheses. How about this one? Negative 5 to the 6th power. Yeah, we get rid of it because this is an even number. What about this though? Negative 2 to the 7th power. Can I do anything with that? Right, there's no parentheses. What about this? Negative 2 to the 8th power. Right, still no parentheses, so I can't get rid of the negative here. The negative is not affected by this exponent. It just sits off to the side here. And the 8 is only affecting the 2. It's negative 2 to the 8th power. It's not negative 2 to the 8th power. Alright. So now, questions on negatives and exponents? Now we're ready for your second rule. Exponent rule number 2. Says x to the n raised to the m power can be simplified as x to the n times m power. Let's look at an example of that. If I have a to the 5th to the 3rd power, I'm going to take the 3, multiply it times the 5 to give me 15. This should hopefully remind you a little bit of the distributive property. A little bit. It's sort of like the distributive property of exponents in a way. Sometimes we call this rule the power to a power, right? Or the power of a power. Let's do another example. If I have z to the fourth raised to the fifth, what do I have?
Z to the 20th.
Z to the 20th.
I get it. Took me a second, but I get it now.
And there's sort of like a little corollary to this rule, a little side effect of this rule, which is if I have x to the n and y to the m, both in parentheses, and those are raised to the p power, then I'm going to have x to the np, y to the mp. So I take this and I distribute it to both of these things in my parentheses. Why does this work? I always like to show you guys why these work. So let's think about a really simple example. If I have x squared raised to the third power, what does this mean? Well, the third power means we multiply this 3 times. So this is the same thing as x squared times x squared times x squared. 1, 2, 3 of them. But I know that x squared is just x times x. X times x times x times x times x times x. It's a lot of x's. How many do I have in total now? If I count those up, I see there are 1, 2, 3, 4, 5, 6 of them. X times itself 6 times is just x to the 6th power, which is what we would have predicted if we had said 2 times 3 is 6. But this is why it works. It's because this is what exponents mean. They mean multiply this 3 times, and then for each of those 3, multiply it 2 times. When we count those all up, there are 6 of them being multiplied together. Okay. And the same thing happens if we have 2 things in the parentheses. Okay? And that's what I want you to pay attention to here. Now this one gets really tricky for one reason. Let me show you that reason. If I have a number inside my parentheses, this third power is going to affect the x, and it's going to affect this 2 separately. Okay? This is like the most common mistake people make with exponents. They say, oh yeah, I know this rule. 3 times 4, that's 12. 2x to the 12. No! Stop! Not 2. The 2 is also raised to the third power. So this would be 2 to the third x to the 12th. This 3 has to apply to both things, both bases, inside of that parentheses. Exponents apply to factors, not to terms. Okay, so the 3 applies to this factor, x to the 4th, and to this factor, 2. Factors are 2 things that are being multiplied together. Right? So 2 is being multiplied times x. It's a separate factor, and I have to apply my exponent to it separately. And this makes sense if we think about what this actually says. 2x to the fourth raised to the third power means 2x to the fourth times 2x to the fourth times 2x to the fourth. If I wanted to simplify this, I have 2 times 2 times 2, right? That's 8, or it's 2 to the third power. And then I would combine my x's. 4 plus 4 plus 4 is 12. So when you see a number inside of your parentheses, don't forget to apply the exponent to the number as well as your variable. All right. Questions on these? Let me make sure we went over everything on this sheet. There are some on here that are somewhat complicated. Let's just do an example. And we're actually going to do an example from your homework. This is number 19. Okay. So we need to simplify this. Okay, all exponent problems, we're always going to be simplifying. The first thing we do with problems like this is we take the numbers and we bring them all out front. So I have 10 times 8. Then I'm going to arrange all the x's together. So I have x times x to the fifth, and then all the y's together. Y to the third, and another y to the third. Now I can start combining things. What is 10 times 8? What does that equal? 80. Now what is x times x to the fifth? Well, I have to remember, this x is really x to what power?
X.
Yeah, this is really x to the 1, right? X to the 1 times x to the fifth is
X to the 6.
multiplying same basis, so I add exponents, x to the sixth, and then y to the third times another y to the third is
Y to the 6.
y to the sixth. I add these exponents. And that's going to be your final answer. We only have each variable one time. Right? So I only have x in here in one place, raised to 1 power. I only have y in here raised to 1 power. And I have all my coefficients combined as best as I can at the front. Let's do one example with parentheses too. So this is number 21 in your homework. Number 2x squared to the second power. 2x squared to the second power. What am I going to do here? I have parentheses and I have an exponent outside. So I distribute that exponent to both things inside my parentheses. So I have 2 to the second power. And I can leave it like that. You probably know that 2 squared is 4. But you can leave it as 2 squared if you want. It's totally fine. You could write 2 squared or you could write 4. Either one would be acceptable for this homework. And then I have x squared squared. So what do I do with these two 2's? I multiply them. And 2 times 2 is
4.
So my answer is x to the 4th. Right, either one of those would be
So 2 to the second power, x to the fourth, or 4x to the fourth.
Yeah. These are the same thing, right? 2 to the second and 4. There's two ways of writing the same thing. All right, questions on that one? So when you have a power of a power, you multiply. When you have a base times the same base, you add exponents. Right? Here we added, here we multiplied. Questions? No questions?